Hello, physics kids. Congratulations, you made it. This is Friday, April 3rd, 2020. This is day 5 of our first week of online instruction. Congratulations, you survived. I survived. We're all winners in this situation. So, what I want to do today is cover the 3 problems that I gave you on the Google form for the April 2nd assignment that we're going to actually go over those answers today. And then I'm going to do a brief concept review of everything that we've covered this week. So I'm going to go ahead and start with the problems here. I need to share my screen. I really love this feature. So awesome. There we go. And let me make my picture bigger. I might be really small. I think you really need to see me because we're wanting you to see your teachers. All right, so let's do this. So I have 2 massive objects which measure from their centers, from center to center. We've got a distance of, what are we writing? Distance of 15,000 meters apart. All right, and object 1 has a mass of 1 million kilograms. Now, to make this easier on myself, I'm going to put that in scientific notation. That's 1 times 10 to the 6th kilograms. And then the second object has a mass of 2 million kilograms. So that's 2 times 10 to the 6 kilograms. And of course, we need to know the gravitational constant. G is equal to 6.67 times 10 to the minus 11. That's a 10. I think I need to start using my pen there. All right, so here's what we're going to do. We're going to find the force of gravity between these 2 objects. We're going to start with our gravitational constant and put that into parentheses, 6.67 times 10 to the minus 11. And then we're going to multiply that times mass 1, which is 1 times 10 to the 6th power. And that's going to be multiplied times 2 times 10 to the 6th power. There we go. That's the top half. Now let's do the bottom half. We're going to take our distance, which is 15,000 meters. Remember, this has to be in meters. And we're going to square that distance. We're going to be able to calculate that force. So I'm going to my calculator. I'm going to enter the following information. Hopefully I don't screw this up. 6.67 EE. We're going to go minus 11. We're going to multiply that times our first mass, which is 1 million. We're going to multiply that times our second mass, which is 2 million. Then we're going to divide that by the square of the distance, which was 15,000. We're going to square that. We're going to end the parentheses, and then let's see what happens. Let's hope this works. Boom. That's my correct answer. So what is that answer? Well, 1, 2, 3, 4, 5, 6, 7 places. If I put that into scientific notation, you're supposed to round that to 3 significant figures. That means our answer is, our force of gravity is 5.93 times 10 to the minus 7 newtons. So I got these massive objects. It's 1 million kilograms, but they're really, really far away. So the gravitational force between them is going to be really, really small. And that's the first problem. Let's go to the second problem. If I went too fast, or you need to refresh your memory on that, or see it several times to help you out, then sure, watch the video several times. If you restart the video and increase my number of views, that would be awesome. All right, so second problem. I have 2 objects, and they measure a distance of 600,000 meters apart. So it is clearly a larger distance than the previous problem. But these objects are far more massive. So mass 1, it has a mass of 2.56 times 10 to the 10th kilogram. That's a massive object. And then the mass 2, we're going to go 2.45 times 10 to the 12th kilograms. There we go. That's a K, that's a K, there we go. Of course, our gravitational constant as usual, 6.67 times 10 to the minus 11th newtons, blah, 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 that giant old unit. So let's see what happens. What is the force going to be? So I'm going to take my constant again, times 10 to the minus 11th, and put that in parentheses. We're going to multiply that times mass. First one, 2.56 times 10 to the 10th, and then multiply that by 2.45 times 10, running out of space here, times 10 to the, what was it again, 12th power. I don't think I wrote that on there properly here. 12th power. And then we're going to divide by the distance, squared, 600,000. Should have put that into scientific notation to make my life easier. All right, let's go to the calculator. Let's see if I can do this correctly. 6.67, negative 11, our gravitational constant, times our far more massive objects now, 2.56 EE to the 10th power. We're going to multiply that times 2 point, whoops, nope, 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 no, no. Times 10. I'm going to have to maybe do this again. Okay, 2.45 EE to the 12th power. Does that look correct? Yeah, that looks correct. All right, so now I'm going to divide that by our distance, which is a larger distance. So let's see what happens. 600,000 meters. We're going to square that, close our parentheses. Let's see what happens to our force. These are far more massive objects. They are farther apart. Let's see how the force, the gravity between them comes out. It says 111.6, but that is actually wrong, I think. Let me make sure. Let me go to my cheat sheet here. My mass was 2.526. That's 10, so I need to add 1, 2, 3, 4, 5, 6, 7, 8 zeros. 2.56 times, all right, and then I should have a mass of 2.245, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and my distance is 600,000 meters. Nope, that's right. It is 11.62. My answer key was wrong. 11.62 newtons. All right, so these are huge objects, these massive objects, but a lot farther distance actually has a force higher than our previous problem. The answer is 11.6. All right, this is why I should double check things before I ever write them down. Our force of gravity, 11.6 newtons. All right, last problem. I know this is riveting watching all this crap. Not really, it's boring. All right, object 1 has a mass of 3.25 times 10 to the 12th. So mass 1, 3.25 times 10 to the 12th kilograms. And it's 356 meters from object 2. Ooh, this is a smaller distance between these two objects. So distance is 356 meters. And then the resulting gravitational force, so F grav is 78.4 newtons. What is the mass of object 2? So we are looking for M2. Do not know. All right, well, we should do what we always should do is start plugging numbers into the equation. And I now know gravity, which is 78.4. That's going to be equal to, we always know our constant, 6.67 times 10 to the minus 11. And I know mass 1, which is, let's do this, 3.25 times 10 to the 12th. And that's going to be kilograms. That's awful. And then I do not know mass 2. I do know the distance, which is 356 meters squared. So anytime we have a problem where there's a variable that we don't know, I always suggest that we work the parts out individually and then we write them down to see what we have. So let's start off with the 6 point. I mean, really what you could do is you could break this off and just multiply. Here, let's use a different color. Ooh, we can multiply the two top numbers, divide by the bottom number squared, and then that's going to be some number times mass of number 2, and then we're going to divide this into our force. So let's do that instead. So it's essentially going to be all of this again, all of that in red, divided into 78.4. So let's do this piece by piece. We're going to go 3.25. Oh, what's going on there? Clear. 3.25 EE to the, my watch is telling me it's time to stand. I can't stand, I gotta work. We're gonna multiply that times 6.67 EE to the minus 11. All right, so it gives me 216.8. Cool. We're gonna take that number and we're gonna divide it by that distance, which was, I gotta find it over here, 356 meters. We're gonna divide that by 356 squared. It's gonna give me that number. And so I'm gonna take 0.00171, all that stuff, and I'm gonna divide that into the force, which was 78.4. So 1.71 times 10 to the minus third is what that comes out to be. Let me write that down because I may not be able to remember that. 1.71 times 10 to the minus third. And we're going to divide that into 78.4. It's going to be a number larger than 1, I'll tell you that much. So clear 78.4. And we're going to divide that by 1.71 second comma to the minus third power. And let's see what happens. Let's see what the mass of this object is. Boom, that's our mass. 45,847.94 blah, blah, blah kilograms. Told you to round that to 3 sig figs, so that would be rounded to 45,800 kilograms, and that is the answer. Let's go back to our black. Our mass 2 should be 45,000. That's not a 5. So erase that again. Okay, there we go. I love this program. This is awesome. Teaching virtually is amazing. Kilograms. And that is the answer to question number 3. So hopefully that helps you out. The problems I give you for tonight, which will be due Monday, which would be April 6th, are going to be a little more difficult problems. And that will be the entirety of that day, which is going over those problems. A lot more difficult. So yeah, you're going to have homework. I'm sorry, but that's just the way it is. So that is it for the homework. I'm going to stop sharing my screen, and there we go. So just to summarize what you have been taught this week, all objects with mass have gravity. The more massive the object is, the more gravity it exerts, the larger its gravitational field. Gravity is a force. It's always an attractive force. Things always come together. My thing keeps on disappearing. They always come together. Why is it doing that? Anyway, so they always come together. The more distant things are, the lower the gravity. You can affect the size of the gravitational force between two objects if you change the mass or you change the distance. And gravity works through it is essentially a depression or a disturbance in space-time, which makes things attracted to each other. They essentially fall into their gravity traps and they eventually will come together. Kind of like the satellites are currently circling around the Earth. They are part of Earth's gravitational field, and then they fall towards the Earth just like you do when you're a clumsy oaf and you fall down. So that is it for today. That is the first week. I hope you enjoyed it. I hope this wasn't too unbearable. I'm kind of in a groove now, so content will be coming at you fast. It'll be streamlined. I hope it'll be amazing. There might be some surprises for next week's videos. So until then, I hope you guys are doing well out there in quarantine land. If you ever have a question, if you ever have problems, if you just need someone to talk to, please send me a message through all the various ways that we have, and I can meet up with you and we can chat. Joey, that is not an invitation for you to harass me constantly. All right, so until then, y'all have a good weekend, and I'll see you later.